Writing inequalities given a written description. Question 1. Type an inequality that represents x is less than negative 5. So first you type x. This is the less than symbol, negative 5. Question 2. Type an inequality that represents x is greater than or equal to 1. X is greater than or equal to 1. Question 3. Type an inequality that represents x is greater than or equal to negative 7 and less than 2. So I have two numbers here, and x is satisfying both inequalities. So I have one that looks like this. I'm going to write negative 7 first. And since I know that x is larger than negative 7, that means the inequality symbol needs to be facing the x. Okay, I know that that's the less than or equal to symbol. I will explain momentarily. X and x is less than 2. Okay, so this is a combined, this is a compound inequality. This part, when we read it from left to right, truly does say x is less than 2. So that's not a problem here. It's this one that most people get confused with. If I were to write x is greater than or equal to negative 7, I'll write it in here. X is greater than or equal to negative 7, I would have it facing that way because I would write the x first on the left side. And then I would write greater than or equal to negative 7. That is a direct interpretation. However, because x is also less than 2, I want to make sure I write it as 1. Okay, so notice in both situations the inequality symbol is facing the x. Okay, because x is larger. All right, so a direct interpretation would be this. But if you combine this, you should have this compound inequality. So just understand what that means in their equivalents. Question 4, type an inequality that represents x is greater than 3 or less than or equal to negative 4. So x is greater than 3 or x is less than or equal to negative 4. Now, normally I would switch these. In fact, I think that's what I'm going to do. I'm going to switch this because usually, we want to write the most negative number first, which is negative 4, and the most positive number second, which is 3. So I just switched it around, but either way, you would have gotten that correct. Task 1, matching a graph to an inequality. Here you have a card sort, and the first thing I'm going to do is I'm going to move all of my inequalities to one side just to organize. Okay, these are all similar, so I'm going to put those together. I'm also going to move my graphs. Here I have like two disconnected pieces. Here I know is also a compound inequality, so I'll move those together. All right, compound inequalities I will put together or group together for the time being. This is a compound inequality because it has two endpoints. If you have like a one-sided arrow type of thing, then that is a simple inequality. So really, if I'm being even more careful, I would do more something like this. Okay, so I know that these simple inequalities that I just moved up top are going to match one of these, okay? And all of these inequalities are going to match one of these. All right, so the first thing, the first card we have is x is greater than or equal to 2. Because I can be equal to 2, I'm going to have a closed circle, okay? So it's going to be this one or it's going to be that one. And then I think, okay, well, what's a number that's larger than 2? And I think, oh, 3, 4, 5, etc. So it must be this one because the arrow is pointing to the right. And notice that 3 is highlighted. 3 is larger or it is greater than 2. And again, because I can be equal to 2, I have a closed circle here. So I'm going to match those two. All right, so that's one match. Here is x is greater than 2, very similar. The only difference is that I cannot be equal to 2, so I will have an open circle at the 2, so it's this one. All right, 2 cards matched already. All right, x is less than 2. So now the inequality symbol is facing the 2. So that means 2 is larger. So I need a number that's less than 2. What's an example of that? 0. So that means that my arrow needs to be highlighting or hovering over the 0. So let's find that. I will also be looking for an open circle on the 2. So here's an open circle, and look, 0 is highlighted because the arrow covers it. So I'm going to group these two together. All right, so this one, these two definitely match, but let's just look at it. This is x is less than or equal to 2. The only difference between the last one and this one is that I have a closed circle because I could be equal to 2. And again, another number that is less than or equal to 2 is 0. So we want to make sure that our arrow is covering 0, which it is, so that we see this colored arrow right here. It's highlighting 0, it's highlighting 1, and all the numbers in between and to the left forever. Okay, so now the compound inequalities. I like these. Let's do these first. One thing I like about the graph is that I know I'm in between two numbers, and it looks that way on these inequalities here. So x is between -1 and 2. So notice in both of these, all the x values are in between -1 and 2. Okay. Nothing exists out here on the outsides, and same thing here, it exists between -1 and 2. Well, the difference is, where do I have an open circle and where do I have a closed circle? Okay, -1 is less than or equal to x. I already can tell that I will have the closed circle on the -1 because of that symbol right here. And less than 2, meaning that 2 you cannot be equal to. You can be equal to -1, but you cannot be equal to 2. So closed circle here, open circle here. So it is this one. I'm going to go ahead and match those two. Move it out of the way. And so I know these two go together, but let's just look at it. -1 is less than x, less than or equal to 2. All right, open circle on -1, closed circle on 2. Open circle on -1, closed circle on 2. Okay, last two. Okay, x is less than -1. What's the number that's less than -1? Well, -2, -3, -4. These are all examples that fit this first inequality. Or x could be greater than or equal to 2. Okay, well, what's the number that's greater than or equal to 2? Well, for starters, I can start at 2 because I can be equal to it. 3, 4, 5, etc. So I'm going to have the open circle on the -1 and the closed circle on 2. Match. And then let's just look at this one, even though we know what's going to match. X is less than or equal to -1, or x is greater than 2. Closed circle on the -1. Open circle on the 2. And it looks just like this. All set. Task number 2, matching a graph to an inequality in slope-intercept form. Which inequality matches the graph on the right? Explain. Your explanation needs to include intercepts or slope, solid dashed line, and direction of shading, and that's solid or dashed. Okay, so I'm looking at this graph, and the first thing I notice is that it's a solid line. Okay, I don't know which one of these options is going to be, so just so I can get a text box to pop up, I'm going to guess this one. Actually, I can pick a different one. I'll pick this one, and the reason for that is because I know it's a solid line. So that means I'm going to have one of these symbols. I'm going to either have the less than or equal to symbol or the greater than or equal to symbol. This allows me to eliminate this option, this one, and that one. So every other option I get to eliminate simply because it's a solid line. Okay, all the ones that I eliminated would produce a dashed line. Okay, so that's the first thing I noticed. Now, for the line itself, I noticed that the y-intercept is -6. Okay, I'm looking at the y-axis here. This is a point that's highlighted for me as well on the graph, and this is at -6. Well, all of these have a y-intercept of -6, so it doesn't help me eliminate any option, but I am going to take note of that simply because I do want to mention intercepts in in my answer here. Now, if you're in slope-intercept form, the x-intercept is not as important as the y-intercept. Okay, so again, the x-intercept is not as important as the y-intercept in slope-intercept form, but you can find it and you can calculate it if you like. Right, the x-intercept over here, this looks like 6, 7, 8, 9. This is -9. So if you plug -9 in here, you should get 0. I'm not going to do that for these because I can figure this out without having to do that. Okay, next thing I want to figure out is slope. Okay, so for slope, you need 2 points, and you need to ask yourself, how do you get from this point to this point? Well, I had to go down 2, and I had to go right 3. I know that's not, beautiful, but that's okay. I went down 2 and right 3. Down 2 means there's a -2 on top and a +3 on the bottom because of I'm going right 3. Okay, so let me type that in here. So to get from -3, -4, which is this point right here, to 0, -6, I had to move down 2 units and right 3 units. Okay, so I know that the slope is -2/3. That means I can eliminate all of these options now. Okay, so I'm going to move it over to this one. Okay, now I only have 2 more options. I'm either this one or the last one because I've eliminated all the other ones by now. Okay, so the last thing to check is the shading. Okay, did I shade above or did I shade below? I'm going to pick a test point, and I like to pick 0, 0, so I'm going to pick 0, 0. Now, because 0, 0 is in the shaded region, I'm going to look for a true statement when I plug it into this one or this one. Okay, I need a true statement because 0, 0 is in the shaded region. If 0, 0 was not in the shaded region, I want to look for a false one. Okay, so I'm going to pick a test point. Oh, that was a lot of space right there. To determine shading, pick a test point. I picked 0, 0, which is in the shaded region, like I just said. This means I will look for a true statement when I plug it in. So let's plug it into the one that I have right here. I did that already, so I'm just going to copy and paste. Give me a second. There we go. Okay, so when I plug in 0 for y and 0 for x, I'm going to see, do I get a true statement? Is 0 less than or equal to -6? No, it's false. So it has to be this last one. Because remember, I was looking for a true statement because it's in the shaded region. But since I got false, it has to be that one. In fact, if you were to plug it in to that one, is 0 greater than or equal to -6? Yes. Okay. Task number 3, matching a graph to an inequality in standard form. Which inequality matches the graph on the right? Explain. Your explanation needs to include intercepts or slope, solid or dashed line, and direction of shading above or below. Okay, so here we go. First thing I notice on the graph is that it's a dashed line. Okay, so all of these actually will produce a dashed line. None of these are greater than or equal to symbols or less than or equal to symbols. So I can't eliminate anything based on the fact that there's a dashed line. I'm going to just guess one just so I can get this text box to pop up so I can explain my thinking. So since there was a dashed line, I know it has to have one of those inequality symbols. All of these options do, so I need to start looking for other things. The next thing I notice is that the y-intercept is 0, -4. Okay, and the x-intercept is 6 comma 0. So this is 6 comma 0, 0, negative 4. Okay, so now that I know that, I can use that to determine whether or not my boundary line is the 6x minus 4y equals 12, 2x minus 3y equals 12, or 3x minus 2y equals 12. So I'm going to use the intercepts to do that. Okay, so I'm going to check the first boundary line by plugging it into the first boundary line. So I plug in x equals 0 and y equals negative 4, okay? And I'm checking, does that equal 12? So 6 times 0 is 0. Negative 4 times negative 4 is a positive 16. 16 equals 12? No, it doesn't. So the boundary line cannot be this. So I can eliminate these two, okay? And I'll come back and I'll adjust my guess. Okay, so now I need to try another boundary line. So let's try the second one. 2x minus 3y equals 12. I plug in x equals 0 and I plug in y equals negative 4. Does that equal 12? This goes away. 2 times 0 is 0. Negative 3 times negative 4 is a positive 12, and 12 does equal 12. So my boundary line is 2x minus 3y equals 12. So now I know I am just, it's either this answer or this one, okay, at this point. I've already eliminated this one and that one. Okay, now let's see. To determine shading, I'm going to use a test point. Okay, and I like the test point 0, 0 when it's not on the boundary line. Okay, and why is that? It just makes my calculations a lot easier. If you pick any other point, you have to do some more calculations. So I'm going to use the test point 0, 0. Since 0, 0 is in the shaded region, I'm looking for a true statement when I plug it in. I'm going to plug it into this one for starters. I think that's the one I plugged into. I'm going to plug it into that one for starters to see if I get a true statement. If I get a false statement, it has to be the other one. So here we go. I plug in 0 for x and 0 for y. 2 times 0 is 0. Negative 3 times 0 is 0. 0 plus 0 is 0. Is 0 greater than 12? Nope, it's false. This is a false statement. So my final answer has to be the other one. So it has to be this one. Oops. It has to be this one. Solving simple inequalities. There are two inequalities we're going to solve here. It says show work on the whiteboard. There are two whiteboards here just to offer extra space for you to do your work. I know that some students still like to do the plug-in steps and the inverse steps, so I'm going to use this whiteboard to do that. Plug-in steps, inverse steps. Okay, so I look at this one and I say, what's the first? So I start with x. I always start with x, okay? I start with x, okay? The first thing that happens to x, you have to remember order of operations says do everything inside the parentheses first. So the first thing that happens to x is that it gets, we subtract 4 from it, okay? So I'm going to type that, subtract 4. Okay, and then after that, this whole thing gets multiplied by 2. Multiply by 2. Okay, and then lastly, I end with the number that's on the other side of the symbol. So end with negative 8. Okay, those are my plug-in steps right there. So now my inverse steps, I must undo this one first. Actually, let me change colors here. I think this will be good. We're going to start here. So that make that green. Let's color code. Yeah, let's color code. What did I did not use purple. Okay. So the first thing you have to undo is this end with negative 8. So to undo that, what is the opposite of end? Well, it's start with. Okay, so I'm going to start with negative 8. Oh, no, I want to new one. Okay, then I have to undo this multiplying by 2. To undo that, I need to divide by 2. Wow, let's click off of this. Okay, divide by 2. Then I undo the subtract by 4. The opposite of subtraction is addition. So let's see. Okay. Ooh, okay. I don't know what just happened there. Add 4. And then I undo this. Start with x, so I should be ending with x. Here, let me just type it first. End with x and then change the color. There we go. I think that's better. Okay, so this is the process I'm going to follow in order to do this. So the first thing I'm going to do is I'm going to divide both sides by 2, because the negative 8 is already here. Okay, the negative 8 is already here, so I'm just going to show that I'm going to divide by 2. Divide by 2. Okay, I'm going to use the math text from now on, okay? So I'm left with x minus 4 on this side, less than or equal to negative 4. And look, notice I didn't divide by a negative number, so I'm okay. I can keep the inequality the same. So I'm going to keep the less than or equal to. Okay, and then I'm going to add 4 to both sides. And when I do that, I get x is less than or equal to 0, because negative 4 plus 4 is 0. Okay, so if you wanted to check your work, if you plug 0 in here, you would get 2 times 0 minus 4. 0 minus 4 is negative 4. So 2 times negative 4 is negative 8. And negative 8 is, in fact, less than or equal to negative 8. So this works. So x is less than or equal to 0. All right, let's do the same thing on this side. Okay, I'm going to do my plug-in steps and my inverse steps. I know it took a while for us to type it the last time, but eventually you'll get the hang of it. All right, so what's the first thing that happens, right? X is like inside parentheses with something else. The first thing that happens to x is that it gets that we add 3 to it. So I'll try to use the same colors. Okay, start with x. Add 3. I'm going to change this color to orange. And then we divide by negative 2. Divide by negative 2. I'm going to change this one to purple. And then we end with 5 over here. End with 5. Okay, change that to red. All right, so inverse steps. You undo this one. So instead of ending with 5, we start with 5. Now, the opposite of dividing is multiplying. So we multiply by negative 2. I'm going to change that to purple. And also, I want to remind myself to switch the inequality, because I'm multiplying or dividing by a negative. Switch inequality symbol. Oh, that's good. Okay, then I need to undo this one, so that means subtract 3. I'm going to change that to orange just to match. And then lastly, I undo this, start with x, and that is end with x. All right, so let's follow these steps right here. I'm going to start with the 5, and then I'm going to multiply by negative 2. All right, so this is really hard for me to do multiplication. I don't like to use an x for my multiplication. I like to use an asterisk, because I don't want my x's to get confused with my variable x's. Okay, so I'm taking my time to do my little asterisk, my little star. Okay, and after this step, I will be typing everything. All right, so these two are going to cancel. I have x plus 3, and in this step it says switch the inequality symbol. So I'm going to switch it from greater than to less than. Okay, and then 5 times negative 2 is negative 10. And then I'm going to subtract 3 from both sides. And when I do that, I get x on this side by itself, and then I get negative 13. Negative 10 minus 3 is negative 13. Okay, cool. So here, x is less than negative 13. Well, let's test something. Okay, what's a number less than negative 13? How about, let's pick a good one. 20. How about 21? Negative 21. If I do negative, if I do negative 21 in here, negative 21 plus 3 is negative 18. Negative 18 divided by negative 2 is a positive 9, and 9 is, in fact, greater than 5. Okay, so I just did that. You can show work and all of that stuff, but yep, this works. Task number 5, solving compound inequalities. It says solve the inequality 3x minus 4 is less than 8, or 2x plus 7 is greater than or equal to 1. Now, I know I did the plug-in steps and the inverse steps in task 4. So if you really want to see how do you do plug-in steps and inverse steps in task 4, go check that out. But I will skip it this time, and I'm going to go straight into solving. It's okay for you to do that. If you understand, you don't have to do it. Okay, so I look at this inequality first, and I'm going to solve this one first. I need to add 4 to both sides to get rid of the 4 over here. Okay, so when I do that, I'm left with 3x is less than 8 plus 4 is 12. Okay, now I need to divide both sides by 3, and I'm dividing by a positive, so I'm going to keep the same inequality. That means x is less than 12 divided by 3, which is 4. So x is less than 4. I'm going to drop the or here. Well, I'm not going to drop it. I'm going to like bring it down, if you will. Now I need to solve this second inequality. In order to get rid of this 7 here, I need to subtract it on both sides. So when I do that, I'm left with 2x on this side. 2x is greater than or equal to 1 minus 7 is negative 6. And now I need to divide both sides by 2. I am not dividing by a negative, so I can keep the inequality the same. So x is greater than or equal to negative 3. So here's that inequality right here. Now let's solve this one. This is an and inequality. This is an and inequality. And so I look at where x is. I got to get rid of that 5 first. So I'm going to subtract 5 from all 3 places. I need to subtract 5. This time I'll actually show you that I'm subtracting 5 everywhere. Okay, I need to subtract 5 from here, here, and here. Okay, and I'll just draw my little bar here. And then negative 7 minus 5 is negative 12. Less than 4x. Less than or equal to 9 minus 5 is 4. So that's what this next line looks like. Now, in order to get x by itself, I must divide all 3 places by 4. Okay, so I'm going to type this all over, but actually show you I'm dividing by 4. 4x divided by 4 less than or equal to 4 divided by 4. Okay, so notice I'm now dividing by 4 everywhere. Okay, and negative 12 divided by 4 is negative 3. I did not divide by a negative number, so I'm keeping the same inequality. 4x divided by 4 is just x, and 4 divided by 4 is 1. So that's what I'm going to type up here. X is less than 4, or x is greater than or equal to 1. Was it supposed to be 1? Yeah, it was. Okay. And this one, -3 less than x less than or equal to 1. Task number 6, inequalities in real-world contexts. You are currently working 2 jobs. Your babysitting job pays $13 per hour, and your tutoring job pays $10 an hour. You need to make at least $500 this month. Okay, so it says let X represent the number of hours you babysat this month, and let Y represent the number of hours you tutored this month. Okay, so we got to figure out how much money am I going to make from my babysitting job. Okay, if I worked only 1 hour as a babysitter, I earned $13. If I worked 2 hours, I earned 13 times 2, which is $26. Okay, if I worked 3 hours, I earned $39. Well, what am I doing? I am taking the 13, my hourly rate for babysitting, and multiplying it by the number of hours I babysat. That is going to tell me how much money I made from babysitting. Now, I'm going to add that to the amount of money I earned from tutoring. Okay, so for each hour I tutor, I get $10. So if I take 10 and multiply it by the number of hours I tutored, which is Y, I get this expression. So now 13x plus 10y is telling you how much money I made in the entire month. I worked this many hours. I don't know how many hours I babysat, and I also don't know how many hours I tutored. But that expression is always going to tell me once I plug that in. Okay, so now it says I need to make at least $500 this month. At least $500. That means I need to make $500 or more. So I want this expression that I just typed to be greater than or equal to 500. Okay, so that is the inequality we are working with. Now here's the question. How many hours do you have to tutor if you babysat 26 hours this month? Okay, so I'll put my final answer here, but I'm going to show my work here. So let's see. I know I babysat 26 hours this month. The number of hours I babysat is represented by X. So I'm going to replace this X with 26. But I'm going to do it here. Okay, so let me just copy this over. 13X plus 10Y is greater than or equal to 500. Okay, next line. I know that I babysat for 26 hours. So 13 times 26 plus 10. I don't know how many hours I tutored. That's what I'm trying to find. So you should not have any values in there yet. Okay, and I'm going to solve. 13 times 26. Okay, if you can't do the calculation in your head, which let me tell you, I can't do this in my head. I want to do this quickly. Okay, I'm going to pull on this calculator. I'm going to do 13 times 26, and I'm going to press enter. When that happens, I will see your calculations. Okay, so 13 times 26 is 338. I'm going to leave that calculator open because I have a feeling I want to use it again. Okay, now I got to get rid of this 338 to get y by itself. So first I must get rid of this. So I'm going to subtract 338 from both sides. So I need to know what is 500 minus 338. And I'm going to press enter again. That's 162. So I'm left with 10y. It's greater than or equal to 162. Now to get y by itself, I divide both sides by 10. Y is greater than or equal to, I can do this, 16.2. But if you didn't know, 162 divided by 10. Okay, that's how we get that. So, I like to interpret this. Now, you can work 0.2 hours. That actually makes sense. Like, you didn't work a full hour, but it's possible to work a partial hour. So you can do that. Don't interpret it as 16 hours in 2 minutes or something like that. If you really want to know how this works, 0.2 hours. Let's see. I want hours. I want to multiply by 60 to know how many minutes. That's 12 minutes. So 16 hours and 12 minutes. You don't have to go that far, but I'm just saying it's probably best that you just stick with the same language that the question gave. I will need to tutor for 16.2 hours if I babysat 26 hours this month in order to make at least $500. Now, if you wanted to round, which I'm okay with, and I understand if you do because that's what we did recently, you could say 17, right? Because 17 is going to be larger than 16.2. If you round it down to 16, this inequality doesn't match anymore. 16 is not greater than or equal to 16.2. So if you're going to round up to the nearest hour, then you can say 17. But in this case, it makes sense to have 0.2 hours. That's fine. When it doesn't make sense, you definitely need to round. Okay, so like if we're talking about the number of people, the number of something that we count, that it doesn't make sense to have like 0.2 of, for example, number of tacos. That was in our recent one. You can't have 0.2 of a taco. So you definitely want to round up in that case. But like I said, time is continuous, so it's okay for you to say this. I think you can just type 16.2 and you'll be fine. All right, ticket to leave. What is a solution? Okay, so each card is going to be matched to one other card. And the first thing I like to do is I like to sort my cards. There's a point on here, there's a point on here, a point here, and a point there. I have two graphs. Okay, so I'm going to move those ish together. And then I have a system, and I have just a simple linear inequality. So these are just one linear inequalities. So I see one line, one shaded region, one line here. Okay, so these kind of go together. And this is a system graphically. I see two lines and two shaded regions, the red and the blue. And here are two linear inequalities here, where if I graph them, it will look something similar to this. Okay, so now I need to check, okay, what is the solution? Let's check the graphs first because those are pretty simple. I'm going to guess this one. Let's look at -2, 3 and see if it is a solution. If I do that, let's see, -2, 1, 2, +3, 1, 2, 3. Okay, well, -2, 3 is not a solution for this one because I'm in my unshaded region. So I'm going to move that back. Let's try 2, 3. 1, 2, 1, 2, 3. Again, I'm not in my shaded region, so I move that away. -3, -2, does that work? 1, 2, 3, 1, 2. Again, not in my shaded region. Okay, so it must be this one, but let's check. -2, -3, 1, 2, 1, 2, 3. Finally, I'm in my shaded region. So these two match. I'm gonna move this down here. Okay. Now let's look at this one. All solutions to this system of linear inequalities must be in the blue and the red shaded region, which is this right here that I'm tracing with my cursor. Okay, it must be in this combined shaded region right here. Combined. All right, so let's figure this out. -2, +3. -2, 1, 2, 1, 2, 3. Okay, I'm only in my red shaded region. I'm not in my blue, so it's not this one. Here, I like to move it up. All right, let's try -3, -2. Let's see, does that one work? 1, 2, 3, 1, 2. Oh, look, it puts me there. Okay, so this is it. You can check the other one. You know it won't work. So now I got to do some calculations. I'm going to move this over because I want to use the calculator here. So let me test this one. X is 2, y is 3. So negative 2, replace x with 2 and replace y with 3. Is negative 1 greater than 5? Nope. So it ain't this one. It must be this one. So let's just double check this. I want to press enter. Let's try this again. Negative 2 times negative 2 plus 3. All right, I get 7. Is 7 greater than 5? Yes, so this is a match. Okay, now I already know these two cards will go together, but I just want to show you what you're going to see. I'm going to replace x with 2. Okay, replace x with 2. I get 3. And I replace y with 3. So is 3 greater than or equal to 3? Yes, it is. So that's a true statement for this one, but it must also be true for the bottom one here. So 3 times replace x with 2 minus 4 times replace y with 3, I get negative 6. Is negative 6 less than negative 5? Yes, it is. So these go together.